Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 2521. Distinct prime factors of product of array. Given an array of positive integers nums, return the number of distinct prime factors in the product of the elements of the array. Okay, note that a number greater than 1 is called prime if it is divisible by 1 and itself only. Okay, an integer val 1 is a factor of another integer val 2 if val 2 is less than val 1 is an integer. Okay, fine. So what is meant by factor? Factor means if a number that divides another number completely without remainder, then it is called factor. And then what is meant by prime number? Prime number are the greater than 1 and it has only two factors. What are they? Itself and 1. That's it. So they are the prime numbers. For example, 7 is a prime number, 5 is a prime number, and 11 is a prime number because 11 doesn't have any other factors other than 1 and 11, right? So that's what a prime number means. Fine. Now let us see some example. Here this is the first example. 2, 4, 3, 7, 10, 6. Okay. When I am multiplying this all entire array elements, then I will get what? This 10,080. Okay. Now it's 10,080, right? Yes. Now it can be written as 2 power 5 into 3 power 2 into 5 into 7. Okay. Now these are the prime numbers, right? Now we have only 4 different prime numbers. Okay, that's why our answer is what? 4. Okay, fine. Now come here. It is 2, 4, 8, 16. So when I am producting it, it will be what? 1024. And 1024 can be written as what? 2 power 10. 2 is a prime number, right? So I am just converting it to the 2 power. Okay, now it is what? Only one different or one unique prime number, right? Prime factor in fact. Okay, now this is what the problem statement. Now how to do this? Okay, the easy and simple brute force approach is that just think about it. Whether we want to take a product, then we want to just find a factor. No, we can directly find a factor of this 2, of this 4, of this 3, then 7, then 10 and 6 individually. Then I can combine it, right? Yes, so that's the mathematical rule. Okay, fine. So by following it, I just wrote a simple brute force solution. Like I will take first this 2, okay, and iterate over 2 alone. Okay, now whether this 2 can divide this 2, yes. Also whether this 2 is prime, yes. So add it into my result. Okay, 2 is added in my result. Okay, now I go for the 4, the second element. Now I will take this. Let me change the color. Yes. Now I will take this 2. Okay, whether 2 can divide this 4, yes. So take it in my answer. Okay, now whether 3 can, sorry, before taking this 2 into our answer, we want to check whether it is prime. Yes, it is prime. That's why we are taking into our answer. Now 3 cannot divide 4. Whether 4 can divide, yes, but it is not a prime. So don't take it into the answer. Now come to the third element. Is 3. Okay, 3 divides this 3 completely, which means what? 3 is factor, right? And 3 is also a prime. Okay, take it. Right, now 7. Okay, now for 7, whether this 2 is divided, no. 3, no. 4, no. 5, no. 6, no. 7, yes. Is 7 is a prime? Yes. So add 7. Fine. Okay, now 10. For 10, 2, yes. And 2 is prime number also. So add it. Okay, now 3, not prime. Sorry, that doesn't divide 10 and 4 doesn't divide 10. 5, yes. And it is prime? Yes. So add 5. Now 6, no, doesn't divide 10. 7 doesn't divide 10. No, it divides 10, but it is not a prime, so don't take it. Okay, now at last we came to the 6. Okay, now for the 6, whether 2 can divide, yes. So add it to my result because 2 is also prime, right? And also 3 is also prime and also divide the 6. Okay, now 4, no. 5, no. 6 can divide, but it is not a prime number, so we don't take it. Okay, fine. Now these are the numbers, or these are the prime factors, and they want the unique prime factors count, right? Okay, if I take them into a set data structure, then I will get what? 2, 3, 7, 5, right? So what is the length of it? It is 4. Hope you understand this. Okay, now what is the time complexity and space complexity for this solution? Okay, the time complexity will be, I'm just iterating to this entire array, right? Let us take the entire array length is n. Okay, into, and the internal loop runs up to what? Runs up to each and every element's count. So the maximum elements count is the highest, right? So let us take that as a worst case. Okay, into m is the maximum element value. Okay, now into, again, for each and every value like this, we want to find what, whether it is prime or not prime. So how we can find it? From 2 up to root n, we want to iterate, and if there is any factors for this, okay, then it is not a prime. That's it, right? So for this, we want a root n. Okay, root n approximately into, we are just pushing into a this set data structure, right? And it also takes approximately log n. So this is a time complexity, huge, right? Okay, now what is the space complexity? It is O of, we are taking the set data structure alone. Okay, so it is O of n, almost, at most we can get n or approximately n. Okay, so this is the time and space complexity analysis for the brute force. Okay, now whether we can optimize it? Yes, we can optimize it by using CU method for finding the prime numbers, right? By using that method, we can optimize it. Okay, how we can optimize it? Fine. So if you don't know about the CU method, I will give the link in the description how to find the prime numbers from 0 to any value like n. Hope you saw the CU method of finding the prime numbers, or you know about the CU method already, and I am just starting the optimal approach. Okay, fine. Now the first step in this optimal approach is to just construct an array of size the maximum value in the array. Okay, the given array. So what is the maximum value in the given array? It is 10, right? So I am just constructing an array of 10 indices. Okay, so the size will be what? 11, max plus 1. Okay, fine. Now the first step is we want to make this 0 as 0 and this 1 as 0. Okay, initially everything are set to be what? A prime, by using what? This 1 as a notation. Now I am just changing 0 and 1 as what? 0, because they are not a prime. Yes. Now again, now first of all I will just iterate here. Okay, so there's a slight difference from the CU method, and now we are using a method. Okay, just observe the difference. First of all, I will be at this 2. Now I am going to check whether this 2 is present in this array. Now how to check it? So we can just check in linear time, or we can just make this into a set data structure. Okay, I will put this into a set data set so that it will be what? Log n times only. It is not a linear time. Okay, I will just convert it in a set in a first step itself. Then I can check it in easy method. Okay, now whether 2 is in this? Yes, yes. So I will add into my set data structure. It is a resultant set. Okay, now again from 2 I will jump 2 times so that I can say this 4 as what? As a prime factor as what? 2. Yes, it's as a prime factor as what? 2. Yes, and also this 4 is not a prime, right? Because it has a factor which is not 1 and itself, which is different than that, right? So I will make this as 0, which means what? It is not a prime. And whether 4 is in this array? Yes, it is in this array, right? Sorry, in this set. We convert as set, right? Okay, now what is the element, or what is a prime number that is jumping over this 4? It is 2, right? This 2. So I'll add 2. So this 2 will be not be added because it's set. In set it will be what? Unique only. Now again I will go to this 6. Now if there is 6, yes, there is 6, and I don't add it also, but I will change this as what? 0. It is not a prime. And then I will go to the 8. Whether 8 is there? No, but I will change this as 0. Now 10 is there? Yes. Whether I can push into this set? Yes, I can push, but there is already 2, right? So there is no change in the set. Okay, now this will be changed into what? 0. Right. Now I am going to the next element. What is the next element? This 1, right? This next element is 1. So I can say this 3 is a prime number. Okay, whether 3 is there in the set? Yes, it is in the set. So add it in the resultant set. Okay, fine. Now jump. Let me change the color. Now jump, and it goes to what? 6. Okay, whether 6 is in the set? Yes, and add 3 here. Already 3 is added. Okay, now again go to the 9. Whether 9 is in the set? No, and make this as 0. Already 6 is 0. That's why I am not making it again 0. Okay, but here 9 is 1. So I make this as 0. That's it. No. I'm going to this 4. Whether 4 is already a prime? No. No. So it cannot be a prime factor for further number. So I will go to a 5. Okay. For this 5, it is prime. Yes, it is prime. Okay. Whether 5 is in this set? No. So jump directly to what? Jump directly to 10. Okay. Now 10 is in this set. Yes. Yes. 10 is in this set, right? Okay. So add 5. Add 5 here. Okay. Now 10 is already marked as 0. Okay, don't worry. Now, next one is I'm going to the 6. 6 is already not a prime. Now I'm going to 7. Whether 7 is in this set? Yes. 7 is prime and also in this set, right? So I will add 7 in my resultant set and move to 14, but 14 is not there. So I will stop here. Okay. Now, again I will go for 8. 8 is not a prime. 9 is also not a prime. 10 is also not a prime, and to the end. Okay, and finally how many elements are in my resultant set? It is 4. So just output as 4. Simple, right? That is slight modification in the sieve method. In sieve method, we go up to what? Go up to square root of n, and also jump from where? Starting from where? While jumping from where we will start from the square of I, right? But here we are just starting and ending to the whole array. That's it. Okay. Now, what is the time complexity and space complexity for this solution? So I can say time complexity will be n for just traversing this entire array, right? This entire, whether it is prime or not array. Okay, and also I am just taking each and every jumps here also. For 2 I am jumping 2 times. For 3 I am jumping 3 times. So it will be what? Approximately log n. It will be small, but approximately it will be what? Log n. And also I am just pushing into this set, right? Sorry. I'm just taking this set, right? I'm just searching in this set whether an element is there or not. So I'm doing some operation. So it also takes some log n times. So that is the time complexity. Approximately we can say what? O of n into log n. Okay. Now what is the space complexity? I can say space complexity will be O of, see here, how many space we have by n space. Okay. Now whether n is the number of elements? No. N is what? N is maximum value. Max of nums. Okay, max of nums. So at first we have done what? We are changing the set, right? We are changing the this array into a set, right? That also takes an operation. So plus O of n, the num. Okay, or I'm just modifying here m. Okay, so m is the maximum. Okay, then here comes n log n for converting my array into a set data structure. Okay, and here also plus m because of the set data structure I have used here. Hope you understand the time and space complexity analysis. Okay, now let us see the code. See here, n is equal to max of nums, then nums is equal to set of nums. Okay, I'm just changing it to set data structure. Now result is equal to set of. Now I'm just taking a prime array where I'm just initializing 1 to the n plus 1 size of that array. Okay, now prime of 0 is equal to prime of 1 is equal to 0. So I'm making the 0th in this and first in this element value as 0. Now for I in range of 2 to n plus 1, if prime of I is equal to 1, which means what? The current element is a prime, then only I want to further jump, right? So if it is the current element is prime, then I will jump from where? I to n plus 1, and I will jumping by what? I, which means what? If it is 2, I will jump 2, skip one element, right? I will jump 2 times like that. Okay, and if j in nums, if my current jump value is in the original set, then what I do? I will take that factor, that prime factor into the resultant set. That's it, and I will make the prime of that j is equal to 0. Okay, and at last I will return the length of the result. That's it. Let me submit it. Yes, submit it successfully. Thank you.